Now, let's talk about naming ionic compounds. Once we've got a formula, be it NaCl or MgCl2 or Fe2O3, we want to know how to name these formulas. Remember, names have to be unambiguous. When somebody says a name, that's got to immediately lead to a formula, and only one possibility for formula. And vice versa, of course. A formula can only lead to one possibility for name. Okay, when you are naming ionic compounds, the first thing you want to name is the cation, the positive ion. Let's look at a periodic table. Nice thing about cations is they're pretty easy to name. The name of the cation is the same as the name of the element. Let me say that again. The name of the cation is the same as the name of the element. So this guy here is lithium. Li plus is also named lithium. This guy here is sodium. Na plus is also sodium. Hence why salt is sodium chloride. So that part's pretty easy. Where it gets to be a little annoying is these elements here. Remember when I told you about charges? I told you there were charges for these guys, they're +1. And I told you there were charges for those guys, they're always +2. But I didn't say anything about this middle part of the periodic table. That's because the charges change. Iron here, for example, is very commonly +2, but it is also very commonly +3. Copper here is very commonly +2, but it could also be +1. These charges change. So because names have to be unambiguous, there has to be something in the name that tells you what charge there is. So what you have to think about when you're naming cations is the cation main group or not? Is the cation... So what you have to think about is the cation a main group element or is it a transition element? A main group element is in column 1 or column 2. Also aluminum over here. All those guys, we know the charge. We don't need to do anything except just name the cation. But these are the transition metals here, and these post-transition metals here also. All of those need something in the name to tell us what the charge is. And what we do is we add a Roman numeral. And the Roman numeral equals the charge. Not the subscript, but the charge. Let's do some examples. Let's go back to our old friend FeCl3. Fe here is iron. But I can't just say iron chloride because, as I just told you, iron can be a +2 or a +3. I need a Roman numeral to tell me which iron chloride I'm talking about. Now, if you look at this formula, we know Cl is a -1. 3 times -1 is -3. So this half of the molecule has to be a +3, because remember, these are all neutral. So the charge on iron has to be 3. And that is a Roman numeral 3. In parentheses, between the name of the cation and the name of the anion. Iron 3. If I had Fe2O3, oxygen is a -2. 3 times -2 is -6. So that half of the ionic compound is a -6. So this half of the ionic compound must be +6, but there's two of them together making up the +6. So again, I've got iron 3. Oxide. I'll get to the names of the anions in a minute. Iron 3. That's how you're going to figure it out every time. The charge, you'll notice it's 3, not a 2. It's the charge of each ion, not the subscript. In case you don't know your Roman numerals, here they all are. More than you will ever need to know for this. Basically, almost everything's going to be 1, 2, 3, or 4. But there's the first 10, just in case you ever need to know that. Okay, so to review. These guys do not need a Roman numeral. These guys do not need a Roman numeral. Aluminum does not need a Roman numeral. And let me tell you another couple of exceptions. Zinc, always a +2. Aluminum's always a +3. Silver is always a +1. All these guys, and hydrogen too, +1. All these guys, +2. All of those, we know what the charges are. They do not need Roman numerals. Every other metal is going to need a Roman numeral. Okay, let's talk anion. You have two choices for anions. One of them is it's simply a nonmetal. Any of these green guys here could be the anion. Most probably it's a halogen. Most probably it's a halogen, oxygen, sulfur, possibly nitrogen, never carbon. The name of the anion ends always in IDE. It's the name of the element with an IDE suffix. Hence why NaCl is sodium chloride. Fluoride, chloride, bromide, iodide, oxide, sulfide, nitride. Those are the common ones. You might see a phosphide, maybe. Always that IDE ending. Or they're polyatomics. Polyatomics, really easy. You just write down the name of the anion. Acetate, hydroxide, oxalate. Whatever it happens to me, you just write it down. Now there is actually a pattern to the names of the polyatomics, sort of. These guys are a good example. A lot of the polyatomic ions are what they call oxyanions. That is, they have oxygen in them. And if they have oxygen in them, one of them ends in ATE. In this case, it's this one. It's chlorate. That ATE tells you there's oxygen in it. I wish I could say to you, 8 always means 3 oxygens, but I can't. Sometimes it's 4 oxygens. Maybe it's 2 oxygens. It's just not standard. But what is standard is, once you know what the 8 is, you actually know a whole series of names. One more oxygen than the 8 has a prefix of per. So this guy here is perchlorate. One less oxygen than the 8 has a suffix of ite. So this guy is chlorite. 2 less oxygens than the 8 has a prefix of hypo. and still that "ite" ending. So this is hypochlorite. Not every polyatomic has all four in the series, but there's a lot where if you know the "ate," one less oxygen is the "ite." There's a lot with that combination. Okay, so to review, if you're going to name an ionic compound, you say to yourself, what is the cation? If you're thinking the cation's a nonmetal, you don't have an ionic compound. That's something else, which we will get to in the next video. Is your cation a polyatomic ion? Just name it. That's all you have to do. Is it a metal? If it is, and if it's not a transition or a post-transition metal, then the name of the ion is the same as the name of the metal. If it's a metal and a transition metal or a post-transition metal, it's still the same as the name of the ion, is the same as the name of the metal, but you have to find the charge on the transition metal and put the charge in parentheses after the name of the metal. Then, once you've named the cation, you're going to name the anion. If the anion is a nonmetal, you just add IDE to the stem of the element name, chloride, fluoride, etc. Or it's a polyatomic anion, in which case the name of the anion is in the table in your book. If it doesn't happen to be in the table, you could say, well, let me find the 8. If it's one less oxygen than the 8, it's an "ite." If there's two less oxygens than the 8, it's a hypoite. If there's one more oxygen than the 8, it's a per8. That's all there is. And when you're writing formulas, just remember, everything has to be neutral. All the positives and all the negatives have to cancel each other out, and the formula of a polyatomic ion cannot change.